as you can see, the title of this lesson is The Real Numbers, and this is a picture of a magnet that I have on my refrigerator at home. And what I'm hoping is that by the end of this lesson, not only will you understand this magnet, but be able to explain it to someone else. Our target today is basically being able to classify numbers. And as you can see, I've got this really cute picture here of a black lab puppy. So, question might be, what does this have to do with classifying numbers? Well, basically the puppy has to do with classification in general, and this puppy can be classified in its most specific level as a black lab, but the puppy could also be called a dog, a carnivore, a mammal, a vertebrate, or an animal. So just like basically all living species can be identified in several different ways, so can numbers. All right, so we're going to move on to that. One question I almost always get is, if we're going to be talking about real numbers, is there such a thing as fake numbers? And yes, there is. In math, we actually call them imaginary numbers. So an imaginary number is either the square root of -1 or a multiple of that. If you think about that for just a minute, you'll realize there's no such thing as the square root of a negative number. Right, so think about this. Remember, the square root of a number is the opposite of squaring it. For example, the square root of 25 is 5 because 5 times 5 is 25. Try squaring some numbers and see if you can get a negative result. So for example, 1 times 1, or 1 squared, is positive 1, but -2 times -2 is 4, or -2 squared is positive 4. So it's impossible when you're multiplying two numbers of the same sign together to get a positive result. So mathematicians actually call the square root of -1 an imaginary number. Right, we're not really going to deal with that much today, but this is something you'll get into in higher math classes. I just wanted you to know where the word real comes from. It's there because there is such a thing as an imaginary number. All right, enough of that. All right, now to the real lesson. First of all, whenever you have real numbers, it's really something that is found in the real world. See how often I'm using the word real? Nearly any number you can think of is going to be a real number. All right, so first thing, real numbers can be broken down into two main categories: rational numbers and irrational numbers. All right, just think about that word for a minute. If someone's irrational, they're not making any sense. Like, for example, if your mother's mad at you, maybe she's irrational, or if a friend is actually talking kind of crazy, you might say they're irrational. Same with numbers. Rational numbers make sense. Irrational numbers do not make sense. All right, let me give you a few examples here, and hopefully we can make this clear in math. A rational number in math is something that makes sense to us, meaning we know exactly how much it's worth. It's something we can put on a number line. All right, so for example, the number 3. 3 is a rational number because we can place it on a number line, right? If this were 0, 1, 2, and 3, we can actually put a dot here, and we know that's where the 3 is. That makes that rational. As soon as you can figure something out, it's rational. Another example would be a fraction. So, for example, if we had the fraction 1/4, that's going to be part way between 0 and 1. It would be right about here. But we can place it exactly on a number line. That makes that rational. Irrational, on the other hand, would be numbers that we cannot exactly put on the number line because we don't know exactly how much they're worth. So, for example, let's say you had the square root of 2. The square root of 2 is about 1.414, but it's not exactly 1.414. If we made it into a decimal, it would actually go on forever and ever. So it would be what we call a non-terminating decimal, which makes it irrational. We don't know exactly how much that is. Another common example is the number pi. Remember, pi is the circumference of a circle divided by its diameter. We don't know exactly what pi equals. We know it's about 3.14, but we don't know exactly if it's 3.14. So since we can't exactly put it on a number line, the best we can do is approximate. That makes pi irrational. All right, to further break this down, let's say we decide a number is rational. Then there are some other categories we can break it into: natural numbers, whole numbers, or integers. Natural numbers are also called counting numbers, and that means they have no zero. Basically, it starts with 1. So 1, 2, 3, 4, 5, etc., in the positive direction. Whole numbers add the 0. So whole numbers start with 0, so 0, 1, 2, 3, 4, again in the positive direction. One easy way to remember that is whole starts with a whole. If you look at the 0 like that, that can help. Integers would be whole numbers and their opposites, meaning with the group of integers, you're actually adding negatives. So for example, -3, -2, -1, 0, 1, 2, 3. This would go forever in the positive direction and forever in the negative direction both ways. But I want you to note, in these three categories, 1, 2, 3, there are no fractions. As soon as you have a fraction introduced, you're only talking about the broad category rational numbers. All right, so what we're going to do next is practice classifying. All right, so hopefully this will make a little more sense as we go through this. What we're going to do is classify these real numbers, although not all of them are necessarily real, but we're going to classify all of them into every possible category that they would fit in. All right, so the square root of 3, this is actually a pretty easy one because this is irrational. As soon as you actually have an irrational number, you're done. It can't be actually classified into any other categories. All right, so you're done with number 1. Number 2, note we have a negative, so you might be tempted to think this is an integer, but it's not because of these numbers after the decimal point. Right? That means this is actually a fraction. Now it is a clear fraction, so since it's a clear fraction, it can be called a rational number, but nothing more than that. All right, let's take a look at number 3. I've got to simplify this one a little bit. Square root of 16 is 4, and 4 over 4 is 1. That immediately lets me know that we've got all sorts of categories for this one. All right, so this one is definitely a natural number. Well, as soon as you've got a natural number, you've also got a whole number. As soon as you've got a whole number, you've also got an integer. This also could be called a rational number because we can place it on a number line. And again, as soon as you have a natural number right here, you've got all of these categories above it as well. We could also say, if we needed to, that it's a real number. All right, so there's that one. All right, if you're looking at number 4 now, this is actually going to be the same as number 3. Since 15 is not a perfect square, that's going to be irrational. If you try to find the square root of 15 in your calculator, you'll see it's a non-ending or non-terminating decimal. All right, number 5 is interesting. Note you've got the square root of some sort of negative. This immediately makes this not real. In fact, if you want to be really fancy, you could say it is imaginary. All right, number 8, going to be the number 6, which is the number 8, is going to be the very same as number 3. It's going to fit all of these categories: natural, whole, integers, rational, and real. So that one can be called by several names. All right, now it's your turn. Right, I want you to actually pause the tape and try these yourself. Do what we did on the last page and list all categories under which each of these can be listed. All right, I hope you had some time to actually take a look at this, and I'd like to start by taking a look at number 1. All right, this one is actually going to be an irrational because 10 is not a perfect square. 9 would be a perfect square, and 16 would be a perfect square, but 10 is not. So as soon as that happens, you've got an irrational number. All right, 3/4 fraction here. This is something you could definitely put on a number line. It's a definite fraction, very clear fraction. This then would be a rational number, and other than that, it's not anything else because remember the natural numbers, the whole numbers, and the integers have no fractions in them. All right, number 3. All right, the number 5 has a lot of categories. Definitely a natural number, which then makes it a whole number. It's also called an integer, also a rational number, and then if we had to name it, it's also a real number. So look at all of the categories for that one. Okay, so I'm hoping at this point you can explain this magnet to somebody. All right, so the question is, why is it that the symbol pi is telling the square root of -1 to get real, while the square root of -1 is telling pi to be rational? All right, my hope is this magnet makes sense to you now. In fact, what I'd like you to do is put this explanation in writing. All right, thank you very much for listening to this. And if you have further questions, you could go back and re-listen to the video or take a look at the internet and look up some of these terms. There's lots of great websites about classifying real numbers.